Hello everybody. Today we're going to try and find a tangent line with the slope of the line tangent to the curve using a formula at the left where a curve passing through the point A f of A has a line that's tangent to the curve, and our job is to find the slope of that line using this limit formula. The limit as h approaches 0 of f of A plus h minus f of A all divided by h. And h, remember, is some small change in x. And we find that limit as the function as h approaches 0. So, all right, let's get a few topics out of the way here. First of all, of course, we're saying we have the function f of x equals 4 minus x squared. And in this case, a is the x value through which this tangent line is going to pass. And if you check this, f of a means then that we're taking the value of the function when x is equal to 1. We calculate that by taking 4 and subtracting the square of whatever x is, and in this case that's 1 squared. Taking 1 squared is 1, of course. Subtracting that from 4 gives us 3, and that's what our y value is right over here. So we can use our formula right here, f of a plus h minus f of a. Well, f of a plus h, remember that 1 is taking the place of a, means that we're taking f of 1 plus h. And of course, f of 1 plus h means that anywhere in our formula that we see x, we're going to replace it with the quantity inside of the parentheses. So this is f4 minus 1 plus h quantity squared. All right, now we're set up to set up our limit right here and find our value. So I'm going to start down here on the left. I'm going to take the limit as h approaches 0 of f of a plus h, so in this case f of 1 plus h, minus f of 1, all divided by h. And replacing that with the appropriate values. Notice, by the way, I'm going to carry my limit notation everywhere I go until the point where I'm actually done having evaluated that limit. I'm going to take 4 minus the quantity 1 plus h squared, minus the value of f of 1, that's f of a, that's equal to 3, all divided by h. Alright, so a little bit of algebra is in order right here. The quantity 1 plus h squared is exactly the same thing as 1 plus h times itself. Those of you who remember either the FOIL method or using special factorization methods means that we're going to take the square of the first term plus 2 times the first term times the last term plus the last term squared. So we actually have 1 plus 2h plus h squared. So that's what we're going to replace in our formula up here where we see 1 plus h squared. So I'm going to just sort of cordon that off right here. We'll come over here. Our limit now looks like this. The limit as h approaches 0 of the quantity 4 minus the quantity 1 plus 2h plus h squared minus 3 all divided by h. In carrying this through, of course, I'm going to take my limit as h approaches 0. Now I'm going to have to do a little bit of algebra right here. The negative is going to have to distribute to each term inside of the parentheses, don't forget. And we're going to have 4 minus 1, which is 3, minus 2h, minus h squared, minus 3, divided by h. And you might notice that the values 3 and negative 3 will cancel each other out here in the numerator, so we can rewrite this limit once more. So we're now going to have the limit as h approaches 0 of negative 2 times h minus h squared divided by h. In the numerator I can factor out h, And that becomes a common factor that I can cancel now with the numerator. So I'm going to factor out that h. I'm going to get negative 2 minus h left in the parentheses divided by h. That common factor cancels. We're left taking the limit as h approaches 0 of negative 2 minus h. And as h goes to 0, this is like saying negative 2 minus 0, and that's just negative 2. So the slope of the line tangent to the curve through the point 1, 3 of the curve y equals 4 minus x squared will be negative 2. Well, that's exactly what we wanted, and so we're done.